Now, we learned that as programmers, we've started to write code that was just pure procedural code to something more organized, using something like object-oriented programming. And we talked about how we had languages like Smalltalk that had this concept of classes and objects to organize our code into these functional boxes. Now, around the same time, there were also this idea of another paradigm called functional programming. And languages like Scheme introduced this idea of functional programming. Now remember, a paradigm is a way for us to think about our code and organize our code. And up until this point, we learned about object-oriented programming. In the next couple of videos, I want to tackle this idea of functional programming. Now, some of the concepts are different than object-oriented programming. But that doesn't mean that you have to pick one or the other, or one is better than the other. Instead, we can use the concepts from both to think like programmers and understand that there's trade-offs, pros and cons to each. And we're going to try and explore that over the next couple of videos. So, what is functional programming? Let's find out. So, what is functional programming? Functional programming is all about separation of concerns, which object-oriented programming does as well, right? It's all about packaging our code into separate chunks so that everything's well organized in each part of our code. And each part is organized in a way that makes sense based on functionality. So when we say separation of concerns, we mean each part concerns itself with one thing that it's good at. We remember in our object-oriented programming section how we had classes to divide up attributes and methods of, let's say, a wizard class and an archer class. And functional programming has this idea as well of separating concerns, but they also separate data and functions. That's how a functional programmer views the world. Instead of combining methods and attributes, we separate them up because they're two separate things. There's data, and this data gets interacted and acted upon. But we're not going to combine both data and functions as one piece in an object like we saw with object-oriented programming. Now, there is no correct definition for what is and isn't functional, but generally, functional languages have an emphasis on simplicity where data and functions are concerned. Because in most functional programming paradigms, we don't have this idea of classes and objects. Instead, functions operate on well-defined data structures like lists and dictionaries that we saw, rather than belonging that data structure to an object. But at the end of the day, the goal of a functional programming paradigm is the same as object-oriented paradigm. It's the idea of making our code clean and understandable, easy to extend. That is, we can grow our code and make it better and better and have others come and extend our code. It's easier to maintain. It keeps our code dry so that we are not repeating ourselves, as well as keeping our code memory efficient because we're not storing information all over the place. Now, when we come to functional programming, we have a very important pillar. And unlike object-oriented programming, where we have those 4 pillars of encapsulation, abstraction, inheritance, and polymorphism, if you want to break things down in functional programming, it all comes down to this concept of pure functions. And this is something that we're going to explore over the next couple of videos. But the idea here is that there's a separation between data of a program and the behavior of a program. So let's find out more about pure functions. What do they mean? What are they? What is a pure function? Well, a pure function looks like this. We have a function. So instead of a box that we had before of objects of all these functionalities, instead think of this as just a simple function. And let's say we give it a list containing 1, 2, and 3. If we give this input into this function, what we would expect with a pure function is for something to happen to this input that every time results in the same thing. So let's say we multiply this by 2, we would receive 2, 4, and 6. Now, a pure function has two rules. One is that given the same input, it will always return the same output. That is, every time we give 1, 2, and 3 to this list, we give it to a function that we create, it should always return the same output. So if I run this function millions of times with the same input, it should result in the same output. And the second point is this idea of a function should not produce any side effects. What are side effects? Side effects are things that a function does that affect the outside world. For example, if I was to print something inside of this function, it affects the outside world, right? Because I'm printing something onto a screen. The screen is the outside world. Or for example, if this function was touching a variable that lived outside of a different scope, that's a side effect. Let's have a look at code to understand this concept a little bit more. Let's say we had a function, and then this function will multiply by 2 a list. So let's just say in li, which will be our list. And in here, what we want to do is loop over the item in the list. And then each item, we want to multiply and append to a new list. So let's create a new list. That will be an empty list. And in here, we'll say new list dot append and do item multiply by 2. And then finally, at the end of this function, we want to return the new list. Let's give this a go. If I say multiply by 2 and give it 1, 2, 3, and let's print out here the output. If I click run, I get 2, 4, 6. Is this a pure function? Let's think about this. The first rule, given the same input, that is 1, 2, and 3, it will always return the same output. No matter how many times I run this, it's always going to give me the same output. So, okay, we passed the first test. What about the second test? That it produces no side effects. Does this produce any side effects? Does this touch anything in the outside world? Think about it. No, it doesn't, right? Nothing in the outside world matters to this function because everything is contained in here. If, for example, instead of having print here, we simply have print in here. If I click run, we get the same output, but does this have side effects? Well, yes, it does. It interacts with the outside world, which is the print statement. The print statement tells me, hey, I'm going to print on whatever the display this machine has. In our case, it's going to print here, but we don't really know what print statement does because it interacts with the screen on this side. So this has side effects. We give control to print, but we don't know what print is going to do. Another example that I can give you is this. What if we have a new list here that we actually define outside, like so? So that we have new list like this. If I click run, I still get 2, 4, 6. But does this have side effects? Well, yes, it does. It interacts with the outside world. And what's outside of this world of a function, which remember is the scope? Well, it interacts with this new list. It appends to this new list. So if a programmer comes along and maybe before we run this function, we decide to say new list, we change it to an empty string. Well, when I run this function, I get an error because now this new list is a string object. So the new list that lives in the outside world of this function can be modified by another developer or by a program, and we wouldn't know about it. And when we run this function, it's going to give us an error. It has a side effect. So ideally, we contain our functions and make them pure. Because as you can see, we're never going to have a bug or an error in our code unless we wrote something wrong here. But because we don't care about the outside world, because everything that we give as an input is always going to produce a good output, it's going to be pure. Now, it's hard to really understand why this is such a powerful concept without having a bit of experience in the workplace. But let me just tell you this, that when you have pure functions, you have less buggy code. You're able to test your code better. It's easier to understand your code. And overall, you have these benefits of not having different parts of your code touching each other and affecting each other, which makes your life as a programmer so much easier. So this idea of pure functions is really important. But the one thing I want you to take away from this is that pure functions is more of a guideline than an absolute. It is impossible to have pure functions everywhere. Because if a function doesn't affect the outside world at all, well, we wouldn't have any programs. We wouldn't be able to display things. We wouldn't be able to save things, such as our game profile. So it's impossible to have pure functions everywhere. However, when you can, wherever you can, functional programming teaches us that pure functions are good. Try to create pure functions and only have few non-pure functions that maybe interact with the outside world that we can go back to whenever we have bugs in our code, because most likely those are the ones that are going to have bugs than pure functions like this. To finalize our concept of functional programming, if, for example, this was our wizard from the previous videos, with functional programming, we would have a wizard object or wizard dictionary that had name, let's say Merlin, and power of 50. And instead of containing these in a class, I would have different methods, such as attack. And this wouldn't be a method, it would be a function because it doesn't live inside of a class. In functional programming, they say, hey, we don't need to combine data with functions. Let's keep those separated. Let's just create pure functions that can be passed anything, like a character. And this way, we keep those two things separate so that we can focus on pure functions and we can focus on data. So that's where the difference is. At the end of the day, it's all about trying to keep our code clean and avoiding bugs in our code, a big problem that programmers have all the time. So it's just a different way of thinking. Let's learn some more in the next video. Welcome back. I want to talk to you about some useful functions that we get that actually allow us to think in a functional programming paradigm. The name of these functions are map, filter, zip, and reduce. And these are very, very useful, very common functions that you'll write a lot when you're a Python programmer. So let's explore them. First one, we're going to start with map. And map actually allows us to simplify the code that we have here of multiply by 2. You see, with map, I have it available as a function, as a built-in function. And we see here that we give the first parameter a function, and then the second parameter is an iterable. A good way to think about it is we want to take some sort of action here, so a function, and then the data that we want to take action upon. So let's say in our case, 1, 2, 3. So what action do we want to take on 1, 2, 3? Well, we want to multiply by 2. So let's say multiply by 2. Now I have to move this down because we have to define the function first. And run it like this. So instead of printing this, let's do print like this. If I run it, I get a map object at this memory location. And map automatically gives us this object that it has created in this memory. So in order for us to actually view it, we have to turn it into a list like this. So if I run this, it says on line 4, int object is not iterable. Well, it's because with map, we no longer need to do this creation of a list, then appending to a list. You see, the neat thing about map is that I give it some data, and then this data gets acted upon by this. And all we need to do with the map function is to have a function that returns this part, item times 2. So instead of having all of this code, all we need to do is say return item times 2. So let's change this parameter to item and look at the code a little bit more in detail. So with the map, I say, hey, I want you to run the function multiply by 2. Notice here that I don't even have the brackets because I don't need to call it. Map does it for me. Map just says, hey, just give me the function, I'll take care of the rest. So I'm not calling the function here. The map is going to call the function for me. I'm just saying, hey, when I call map like this, I want you to use this function at this memory address and use this data. Remember our functional programming paradigm. We have data that gets acted upon. So we separate those two out. Now, this function is going to take each one of the items in our iterables. In our case, first time around, item will be 1, then 2, then 3. And then all we need to do is to return what effect we want to have on that item. In our case, it's 2. So by doing this, map automatically runs this function for us and loops through all the items in the iterable and returns for us a new map object that we're going to convert into a list. If I run this, I get 2, 4, 6. Now, here's the neat part. If I do, let's say, my list, and I say 1, 2, 3, and I change my list over here like this, and at the end also print my list. If I click run, you'll see that my list hasn't changed. Remember, a pure function is a function that doesn't affect the outside world. And this way, map allows us to create a whole new list that doesn't modify my list. So my list is immutable, right? We don't change it. And all it does is map function takes care of it and returns a new list for us. But we don't affect the outside world. There's no side effects in this function. We're simply just multiplying item by 2, but creating a new list out of this. And every time we give it the same input, it's going to result in the same output. Very, very cool. And map is extremely useful because anytime we have something that we can iterate over and we want to change, let's say we have emails or usernames, and we need to update the usernames to, let's say, be all capital letters. In that case, we can iterate and using the map function, change all the usernames in our list to, let's say, capital letters. Map is going to be one of those functions that you use a lot in your programming career. And I hope you can see here how clean and nice it is, again, using functional programming paradigms. Let's move on to the next one. Let's talk about filter next. Welcome back. Let's talk about filter. Now, based on the name, you should guess what it does. It filters things for us. So with map, we always got the same number of items back, right? We had 3 items and we got back 3 items. We just mapped over each item. With filter, we can sometimes receive less than what we gave it. We're filtering some of our results. So let's create a new function. Instead of multiply by 2, I want to create a function. And this function, what are we going to do to the items? Let's say if items are check if odd. So we're going to say, hey, are these numbers odd? And only return the odd numbers. So check odd is going to receive an item. And this item is going to be acted upon. And once again, we have to return something. What are we going to return? Well, the filter function is going to try and receive a true and false value or a Boolean value, whether it should be filtered or it should not. So if we want to check if a number is odd, well, we can say item modulo 2, because modulo 2 is going to divide the number by 2, and if it equals 0, then it's even. Right? So I can say doesn't equal 0. So if the remainder doesn't equal 0, it's going to be odd. And we just simply return this. Again, this is going to evaluate into a Boolean expression. And based on the Boolean expression, filter is going to say, if it's true, I'm going to keep it in the list. If it's not, I'm going to remove it or not add it to the new list. So let's check this out. Instead of map, let's do filter. And here, we'll do check odd. Or you know what? I don't like this name. Let's do only odd. Like that. If I run this, look at that. I've filtered and removed the 2 because that's an even number. Again, notice here how I'm not calling the function, because filter accepts a function, or what we call function signature. That is, hey, just tell me where I can find what memory space I should go to for what action to take. And it's going to say, hey, give me the data, and I'm going to go and run this function on each item. So when we go to 1, it's going to run this function with 1 as the argument. 1 divided by 2, well, that definitely doesn't give us a remainder of 0. So that's going to return true, and that means I'm going to add it to the new list that we create. When we get to 2, though, because this is going to return false, it's not going to add it to the list. Again, if let's say we have a list of users, in that case, we might want to filter out based on users starting with the name A. We can use the filter function to filter through all the usernames and only have a new list with the usernames with letters starting with A. Another very useful function, and as you can see, we kept everything pure. It creates a new list for us. It doesn't modify the original list. So we're keeping that functional paradigm in mind. And once again, the beauty with both map and filter is look how simple the functions become. Everything is just nice and simple, and mind you, they can get a little bit more complicated, but all we need to know is, hey, what should I do to the item and what should I return? That's the only thing that they're concerned about, instead of having these massive, massive functions that try to do everything. All right, let's talk about zip next. Let's talk about zip. How can we use zip? Well, let's create a new function. And the zip function works kind of like a zipper. We need 2 lists or 2 iterables and we can zip them together. Let me show you what I mean. Let's say I have my list and then your list. And this your list will have 10, 20, and 30. Make sure that it's a list. There you go. And in here, with the zip function, I can simply run zip. And in here, I give it as many iterables as I want. In our case, 2 iterables. So I'm going to give it my list and your list. Let's close that out. Add one more bracket. And if I click run, look at that. What just happened here? Zip, like a zipper, takes the 2 iterables and grabs the first item from each and zips them together like a zipper. So 1 and 10 get added to a tuple together. Then 2 and 20 get added to a tuple together. And then 3 and 30 get added to a tuple together. What if this was a tuple? Like this. And I click run. Doesn't matter. It's an iterable. It's going to zip the items together. Now, this may not seem that useful to you now. It's actually a very important function that, because it's so generic, can be used in so many different things. For example, if we had from a database, we collected all the usernames from one column in a database, and then maybe from another part of the database, we collect all of the phone numbers, and they were all in the same order. Well, we can combine these into a tuple using zip that has the username and the phone numbers attached to them and create a whole new data structure. And if I had another list here, let's say their list. And this one has 5, 4, and 3. I can add, again, their list as well. And if I click run, you see that I can keep zipping things together. So zip iterates over each one of these lists or data structures and zips them together. Once again, noticing that we don't modify any of our current data. Instead, we create a whole new one. Very, very nice. What about reduce? Let's find out more in the next video. Let's talk about the last one, reduce. And this is a bit advanced and it might be a little bit difficult to grasp at first, but it's good to know that it exists and you can learn more about it by practicing it and reading some documentation on your own. Now, reduce doesn't come as part of the Python built-in function. In order for us to use reduce, we have to do something like this. Now, you've never seen this before, and this is something we're going to get to in the modules section of the course. But essentially what's happening here is when we downloaded Python interpreter and the Python package, in our case, this REPL already does it for us, we can import something from these functools. And functools are what we call a tool belt that we can use for functional tools that comes with the Python installation. And from there, there's a specific function that we can import. So I'm saying, hey, from functools, from this tool belt, I want you to import the reduce function so that we can use it in our code. Again, something that we'll cover later on in the course. So for now, just copy and paste this line. Next, let's remove some of our list and here use reduce. Now, with reduce, we're going to need a few things. First, we need the function, and then we need the sequence or the data. So what's the function going to be? First of all, our data will be our my list. So I'm going to say my list. And the reduce function, allows us to do something interesting. I can give it, let's say, a function, and this function, we'll call it the accumulator. And the accumulator takes two parameters. And remember, this is going to be called by reduce. So reduce is going to be in charge of giving these two parameters from the data that we give it, which is my list. The first parameter is going to be what we call the accumulate, or in my case, the ACC. And then here is going to be the item. Now, where it gets really interesting is that when we first pass my list from the reduce, we'll get the first item. The first item will be in this parameter. However, what's this ACC initially? Well, if I just remove the brackets here and show you reduce, you see that we have the function, the sequence, which in our case will be our list, and then the initial. An initial is what the accumulator is going to be. So once again, let's say that we're going to have the accumulator function that we're not going to call yet. Reduce is going to do that for us. I'm going to give it the list or the data that we want to iterate over. And then I'm going to give it an initial value of 0. So we have three parameters here, or three arguments that we give it. Now let me close the brackets. There you go. Let's make this a little bit bigger here. And make sure that I can spell. Now in here, the first item will be whatever is the first item in my list. And then the accumulator is going to default to 0 if we don't give it anything, or in our case, we have said that the accumulator is going to be 0. So the first thing we're going to do is we're going to return accumulator plus item. Okay, so let's go through this one by one. I'm actually going to print here the accumulator and the item just so we can see, and then I'm going to run this code. Line 15, int object is not iterable. And this is a little tricky, but we actually don't need the list anymore because reduce is going to do something interesting for us. So let's just remove this for now and just return whatever reduce gives us in the print. If I click run, look at that. All right, so what just happened? Let's have a look. Reduce allows us to reduce something, some sort of value from the iterable that we give it. So let's go step by step. We have my list, and my list is going to be applied to accumulator through reduce. The accumulator is going to take my list, and the first thing it's going to do in the first pass through is going to say, hey, what's my accumulator going to be? I'm going to set it to 0. So the first pass through accumulator is going to be 0, and item is going to be 1, which is what we see over here. And we're going to add it, 0 plus 1. So now we have returned 1. Now the second pass through, what's going to happen? The second pass through, the accumulator is going to be what this returned. So the next pass through, whatever this is returned is going to be filled into accumulator. So in our case, 0 plus 1 will be 1. An item will be 2. 1 plus 2 is going to be 3. So 1 plus 2 equals to 3. So the next time around, the accumulator is going to be 3. And what we pass through is going to be 3 as well, as you can see here. And 3 plus 3 is 6. We've just accumulated all these values and returned one single number, 6. We've reduced our list into some sort of data that we've manipulated using, in our case, accumulator. But I could have done anything I wanted here. So if, for example, I change this to now equal 10, what do you think will happen? If I click run, I get 16 because I started my initial accumulator with 10. So it was temp plus 1, then so on and so forth. Now, reduce is really, really powerful because you can do a lot of things with it. It's really, really flexible. And actually, underneath the hood, functions like map, filter are actually using this reduce underneath the hood. So you can actually build your own map and filter function using reduce. Again, reduce is a little hard to understand at first, and it does take a bit of practice to really use it. But it's one of those things that advanced programmers really, really love, and you'll see more and more of throughout your career as you get better and better. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about something that I really, really love, and it's called Lambda expressions. And Lambda is actually a computer science term that really is compatible with this idea of functional programming. You see, Lambda expressions in Python are one-time anonymous functions that you don't need more than once. What does that mean? Well, Lambda expressions are really, really useful when you're using them for functions that you only use once. Remember how we talked about functions are useful because we can define them and then use these functions over and over and thus save us from copy and pasting code? Well, Lambda functions are for those occasions where we have a function, but we only need to use it once. And then the second part is that they're anonymous functions. That is, because we only use them once, we don't need to have a name for them because, we don't really need to store them anywhere on our machines. I just want to use it once, just run it, and then I'm done with it. Just throw it away. So how does a Lambda function look like? A Lambda function looks like this. We say Lambda in Python. Let me just add a bit of space here, just so we can see. We say Lambda, and you can see that it's highlighted blue. And then I'm going to say a parameter that this function is going to get, and then a colon, and then some sort of a function here, and the parameter. Or instead of function, it'll be some sort of a manipulation that we do. So let's say action that we want to take on a parameter. All right, this still looks confusing, so let's actually try to implement it in our functions that we've created. So let's say multiply by 2 is one of those things that we're only going to use once. I only want to multiply by 2 this my list, and then I'm done with it. I don't need to save it to memory. It's just extra piece of code. I don't need this. How can we do it? Well, let's say we have the map function back here, and let's turn it into a list. And for now, I'm just going to minimize these, so we only focus on the multiply by 2. And here, let's go back to multiply by 2. Remember how we had it before. My list, and we don't need the third parameter, just like that. Now, with a Lambda function, I can say, hey, I don't need to create a whole new function. I'm only going to use it once. Let's just remove this entirely. And instead of using multiply by 2, I'm going to say Lambda. And here, I'm going to give it the parameter. What parameter am I going to receive? Well, I'm going to receive an item from my list. And then in here, what do we want to do to my list? Well, I want to multiply it by 2. All right, could this work? Let's give it a go. I'm going to run. Whoa, did you see that? I didn't even use multiply by 2. As a matter of fact, I can just delete it. And if I click run, everything still works. Now, why is this? Remember, Lambda expressions are one-time anonymous functions. There's no name attached to this function. This is the function right here that you don't need to run more than once. So once the interpreter runs this line of code, it doesn't remember this. It just forgets about it, but it performs the action for us. In our case, we're saying, hey, I want to create a Lambda expression. I'm going to take an item from my list, and then I'm going to multiply that item times 2, and this automatically returns it. Again, the order that we do is lambda, then we give it the param, colon, and then the action we want to take. In our case, it'll be param and whatever action we want to do, like so. In our case, item times 2, and this automatically returns. How cool is that? This is a really nice feature of Python to keep your code really nice and clean and not clutter with all these functions. And other languages might not have lambdas, but they are sometimes called anonymous functions. Again, something that we've discussed why they're anonymous. They're just like normal functions and even behave like them, but we only use them once and they don't have a name. But you can see here that it makes things a little bit cleaner. What if we try to do filter now with a lambda function? Well, if you want, you can pause the video and try yourself, but it should be fairly easy, right? If I do filter, I can do lambda, item, and then item. We'll just copy this. So the action that we want to take on the item is this. And if I run it, again, it works. How nice is that? No longer need this function either. Very, very nice. What about reduce? Can we use reduce with lambda? Sure, why not? Let's say here, we'll say reduce. We're going to remove the list from here because we're just producing a single value. I'm going to say lambda item. Remember, reduce accepts 2 parameters, the accumulator and then the item. So I can just give it 2 parameters like this and then say, what do we want to do? Well, I just want to add accumulator with the item. So if I do my list here like this, and I click run, check that out. That works as well. How cool is that? Again, we no longer need the accumulator, and now we just have one-line functions that I can just run and immediately reduce the list. Very, very cool. We're going to be exploring lambdas a little bit more, especially in the comprehensions part of the course. So if you're still not 100% on them, don't worry. We'll have more use cases and why they're useful later on in the course. But lambda expressions, I really, really like. They make your code really, really small. However, they do make the code a little bit less readable. So it is a trade-off where you can get really clever with lambda expressions, but make your code really confusing to others. So you do want to be careful. For now, we're done. I'll see you in the next video. Let's do a fun exercise to test our understanding. And we're going to use lambda expressions. Now, I want you to create a lambda expression that is going to square our list. So let's say we have my list, and this my list will have 5, 4, 3. Now, I want you to create a one-line lambda expression that's going to print for us a squared list. So 5 to the power of 2 will be 25, 4 to the power of 2 will be 16, and 3 to the power of 2 will be 9. So a list that contains those values using lambda expressions. So that's your first challenge, is to square. The next challenge, and this one's a little tough, we're going to do some list sorting. Let's do square here, just so you can see. And in this list sorting, I have a list. And this list, well, it's a tough one. We have a list that is a tuple of 0, 2, then a tuple, let's say 4, 3, and a tuple, let's say 9, 9, and then finally a tuple that is 10, -1. Now, what I want you to do is to sort this based on the second value. Ooh, make sure this is a comma. So that is, I want this to be sorted so that this tuple is first because -1 is the lowest. Then this tuple because 2 is the next highest. Then this tuple, then this tuple. So how can you do that using lambda expressions? Now, this is a tough one, so if you don't get it, don't worry. Pause the video here, take your time, see if you can solve this. Otherwise, I'm going to get going with the answers. This one should be fairly easy to you, right? We can just simply do a map function. Or you know what, let's just say new list is going to equal a list that we're going to map over. And in here, nothing we haven't seen before, I'm going to say lambda number is going to be number to the power of 2. And the list that I'm going to give it will be the my list. If I run this, there you go. Nice and easy. Nice, easy one-liner. What about this one, though? This one's a little tough, and you really have to think about it. We've learned that we have the dot sort method, right? And the sort, actually, well, let's see what happens if I just sort like this. If I do print a dot sort and I click run, I get none because it modifies the list in place. So let's just print a after we have sorted it. If I click run, all right, it looks like it's sorted with the first key. What if we move this in here in the middle and click run? All right, looks like it's sorting it for me, but it's sorting it based on this first item. But I want this second item, or what we call the second key, to be the sorting factor. And if you see here, if we do sort, I have to give it a key. And we want the key to be 2. So how can we do that? Well, we can do something like this. We can say key is going to equal each one of the second keys. And we can use a lambda expression here. We can say lambda, so the default parameter would be lambda of x, and then simply say x1. Let's go over this. What I'm saying is, hey, I want you to run the sort function. And the key for the sort function, when I'm sorting through everything, is I want it to iterate over each item that I'm going to get. That is, x is going to be this tuple. And I want you to use the value which we're going to return, which is the second one. So the key is always going to be by the second item. Now, if we run this, look at that. We're able to sort by the second item. Now, if you didn't get this, don't worry. This is quite tough. And it's hard for you to get used to the syntax or know that sort worked in this way. But the goal is to show you that this is a common thing that you can do with lambda functions in a way to make sure that you can sort with different keys. For example, this would work with a dictionary or another list inside of a list. This is a common way to adjust your sorting, and it's a pattern that you just have to remember. But it shows you the power of lambda, where we don't really have to write these complicated functions. If we really just needed a one-time function and just a function that returns something simple, lambda is a great tool to use. But if you didn't get this, like I said, don't worry. This is one of those things that you'll just have to remember. Let's take a break, and I'll see you in the next one. Let's talk about something that's quite unique to Python, and makes things really, really nice as Python programmers. And it's called comprehensions. It's one of our key terms, comprehensions. What are they? Well, they're actually called list comprehensions or set comprehensions or dictionary comprehensions. And these are some of the data types that we have in Python. And we're able to use comprehensions with these three data types. By the way, as I'm recording, there are some birds chirping in the background. I thought it would be nice to just record with birds chirping in the background. I think it'll be peaceful for you. If you get annoyed, I'm sorry. But hey, the birds have to have fun as well. Okay, so what are these comprehensions? Well, they're a quick way for us to create lists or sets or dictionary in Python instead of perhaps looping or appending to a bunch of items to lists. So let me show you. Instead of doing something like my list equals an empty list, and from here I'll do something like for character in hello, my list dot append character, just so I can create this list finally. So let's say my list, and we'll print this out. If I click run, I created a list that contains the characters from hello. All right, but is there a faster, cleaner way of doing this? And yes, there is with list comprehensions in Python. Again, it is quite unique. You don't see it in a lot of programming languages, but people that use Python really love this feature. And I do too. So how can we do this using a list comprehension? Well, the format we're going to follow is like this. We're going to say param for param in iterable. So when I say param, I mean parameter, or in our case, it could be a variable. So we can name it whatever we want. So let's name this character, like we did in here, and then character, like we did in here. And then we want an iterable. In our case, we'll say hello. So that if I remove this and I click run, I get the same thing, just like that. So upon creation on line 3, I create a list that contains character in hello. I do a for loop in here, and I create the list. So the way that I like to think about it is, hey, create a variable. And then we're going to do a for loop saying, hey, for each variable in the iterable, added to the list. Okay, let's expand upon this. Let's say I wanted to do something else. Let's call it my list 2. And I want to create, let's say, a quick list with numbers ranging from 0 to 100 or 0 to 99. How would I go about doing this? Again, using list comprehension, I'll say number for number. And then what's the iterable I'm going to use? Well, I'm going to use a range and say 0 to 100. So that if I click run here, look at that. I get a nice long list pre-populated with all these numbers. How cool is that? Okay, but here's my challenge to you. What if I wanted this, but all the numbers should be multiplied by 2? So I want a list where this equals to 0, this is 2, this is 4, this is 6, this is 8, this is 10, so on and so forth. How can I do it? Well, we can actually expand upon this so that my list 3, this time around, will use the same for loop that we've seen before, like this, but instead of just the variable, this is now an expression of how we want to act upon each character, just like we saw in Lambda expressions. So I can now say num times 2 for these items. So now if I do my list 3, Hey, check that out. That's pretty nice, isn't it? Okay, let's make it even more challenging. Let's say my list 3. Now let's make this a little bit bigger here. My list 4, I want to change it so that in my list, I still keep here what I have, the numbers, but I want to only keep the even numbers. In this case, all of them are even because they're multiplied by 2. But if, for example, we do to the power of 2, and let's comment this out for a second and click run, we see that some numbers aren't even. So I want to keep these numbers, but only the even ones. How would I go about doing it? Well, in this case, we have a new way of creating this list expression. We'll do the exact same thing that we've done here, so I'm just going to copy that. But at the end, remember, we now have an expression here, something that we're going to do to affect whatever the item in the iterable is. We're going to loop through things. And then finally, after this, we can say if, or we can do an if condition. So let's say in our case, I'll say if num modulo 2 is equal to 0, only then add it to the list. So if we click run, and make sure that it's list 4, click run. Look at that. All of these are even numbers. So let's look at this format. Remember, these are called list comprehensions. It's a way for us to quickly create lists with Python instead of looping and using append or things that we've seen before. So it's a shorthand form for us to do things unique like this. The way we're able to do this is to have an expression here of what we want to do with each item that we're iterating over. We loop using a for loop through an iterable. We give it a variable, which we're going to act upon. And then if we want, we also have an option to add a conditional and say, hey, only include it into the list based on this condition, based on a true or false. Very, very cool. Now, although list comprehensions are really nice because they're just simple one-liners, it can get pretty confusing. Looking at this code, you have to be really familiar with list comprehensions to really understand what's going on. So although this makes code shorter, maybe even cleaner, it does take away a bit of its readability. So it might be better to just create a descriptive function like generate list of even numbers or something along those lines, so it's more descriptive and another developer might have a better idea of what's going on. So it's always a trade-off. Let's take a break and talk about set and dictionary comprehensions in the next video. Let's talk about set comprehensions and dictionary comprehensions. Now, this first one is actually quite easy. You see, because we can do the same thing that we've done with lists. We simply change these bracket notation to a set, which is a curly bracket like this. So that if I do my list, the first one, I get a set. Same with the second one. If I go like this, my list 2, just like that. And I think you get the idea. Let's do one more on the final one. So my list 4. Again, you're able to do set comprehensions on sets as well. A quick way for us to generate sets. And remember, sets only allow numbers that are not duplicate, only unique items. What about dictionary comprehension? Well, let's do something like this. Using the same formula we've used, let's create a my dict. And in here, we're going to create a key and a value, just like that. And this key value can be acted upon. So in our case, let's say we want to multiply the value by 2, or to the power of 2. So this is what we want to create, a key-value pair, and the value gets acted upon. Now in here, I'm going to say another for loop. For, so let's say key, value, and then in, well, in what? What are we going to iterate over? Well, let's think here. In order for us to create a dictionary, we need both a key and a value, right? So I need to pass it an iterable, but I need to pass it an iterable like a dictionary that has both key and value. So we can do something simple here. We can say simple dictionary that will have A as 1 and B as 2. And now all we do is pass simple dictionary in here as an iterable. We grab the key and values by doing dot items, which we've seen before. And let's make this a little bit bigger. There you go. Let's put it all the way, just so we're all clear. It's all on one line. And now, let's just see what happens, and we'll go through it step by step. I'm going to copy this and, oops, paste it. And if I click run, look at that. I have a new dictionary that has A equal to 1 and B equal to 4. Now let's go through it one by one. Just like we saw with list and set, the first part is what we want to do with the data. In our case, I wanted key and value, which I was going to extract here in our for loop. I could have named this whatever I want though. I could have done K and V, and you might see this commonly in Python code, just short term for key and value. And then I wanted to do the power of 2 to the value. So then this is what I wanted to do. This is the action. This is the for loop that we did. So the for loop was, hey, extract the key and value using the dictionary.items. Remember, I needed to have 2 values so I can fill in key and value. And then the value you multiply by 2, or to the power of 2. So we get that. If, for example, I wanted to add an if statement and say, hey, I only want you to add if the value is even, so let's say modulo 2 equals 0, only then I want you to add the dictionary. If I click run, only the even value 4 gets added to the dictionary. Very, very cool. Again, this makes your code a little bit less readable. So it's just a shorthand for you to use, and maybe if you see it in code, you at least know what it is. But you should be careful not to be overly clever and do these single line dictionary comprehensions just because you can. Just to solidify our knowledge, let's finish up with another example. What if instead I have this? I want to do a for number in a list 1, 2, 3. So we no longer have this dictionary, but we still need to include a key and a value pair. Could I do it so that maybe the item is the key and the item multiplied by 2 is the value? How would we do that? Pause the video and give it a go if you want. Otherwise, this is how we do it. We simply say number is the key and the value will be num times 2. Just like that. Nothing too difficult, right? If I click run, there we go. We're able to use comprehensions, list comprehensions, set comprehensions, dictionary comprehensions as a way to create lists with Python, as a way to create these data structures really fast with Python. Let's take a break and do an exercise in the next video. Welcome back. Remember this exercise that we did a few videos ago, where we had some list with letters, and I wanted you to find the duplicates and return them in a list of duplicates. In our case, we wrote this function with loops that returned b and n because both b and n were duplicates in the list. Now, this is going to be a tough one. Using what you learned about comprehensions, is there a way to do this neater? For example, I want you to say duplicates like this and create a comprehension in here that returns this exact same answer, b and n. So that if I print duplicates just in one line, I can find the duplicates. You can use set comprehensions, you can use list comprehensions, dictionary comprehension, whatever you need. Give it a go, really think about it. You can pause the video because otherwise I'm going to go with the answer. What I'm going to do is let's remove this and just start here. Now, the first thing I want to do is I want to create a list comprehension. What should I do here? Well, first, I know that I'm going to create a variable. So let's just call it x. And here, I'm not going to modify any of this. I'm just going to keep x the way it is. So x is going to represent a, b, then c, then b, then d. And I'm going to loop over and say for x in the list, some list, I want to only add the items that are repeated. So how can I check for that? Well, we can do an if statement, and in here, I'm going to say, well, some list dot count. Remember, count tells us how many times an item appears in the list. So we just give it the x parameter, so a, to let us know, hey, how many times does a appear in the list? How many times does b appear in the list? How many times does c, does b, so on and so forth. And our if statement should check if the number is greater than 1, right? So let's see what happens when I return this. If I click run, look at that. I get b, b, and n. All right, that's good, but I want to only have them once. I only need b and n. I don't need to know that, well, I don't need a list of 4 letters. So how can we do this? We know that we can create a set like this, right? I can say set and wrap it in here so that the entire list gets turned into a set. So we give this to the set, and then what happens? Oh, and this needs to be brackets, right? Because this is a function. So this is the set function that Python gives us. So if I run this, look at that. I have n and b. Almost done because, well, this is now a set. I asked you to return me a list. So what should we do? Well, we now can create a list out of that set. If I click run, there we go. We have our duplicates all in one line. Mind you, a very long line. And maybe this isn't the most readable code, but that's pretty cool. Now, this is a tough one. Maybe you didn't get it the first time around. It's okay. This is just something that you have to practice. You have to do a bunch of problems, and you'll get used to eventually as you progress through your career. But that's it for comprehension. I'll see you in the next video.